In the last section, we became quite familiar with the concept of conditional probability. Now we're going to change tack quite a bit and talk about random variables. Let me give you just an idea of where we're headed. So in this section, we'll talk about random variables. We'll discuss discrete random variables specifically. We'll talk about probability distributions, expectation, and its properties, and variance and standard deviation. So let's begin with just introducing random variables. And I'll use an example to motivate this. So let's say that your experiment is your morning commute, and there are 3 outcomes. So you could catch the 8 o'clock train if you're really running on time, or if you're a little late, you'll catch the 8:15 train. And on some really bad days, the train's not running and you have to take a bus. So as we've done in previous videos, we could say that there's a probability associated with each of these events. Say the probability you catch the 8 o'clock train is 0.6, and the 8:15 train is 0.35, and the bus is 0.05. But presumably there's some greater reason that you're interested in this experiment. And let's say that you care about being on time to work. And so we can associate a number with each of these outcomes. Let's say that you were 0 minutes late if you catch the 8 o'clock train, but if you catch the 8:15 train, then you're 15 minutes late to work. And if you have to take the bus, then you're 30 minutes late. Now this is perhaps why you care about the experiment. And this motivates the concept of random variables. So a random variable is a numeric value that's associated with each outcome in a sample space. They're often denoted by capital letters like X and Y, and you'll see that throughout the slides. And they have some advantages. Often we're more interested in, for example, the minutes late to work rather than actually which mode of transportation you took. And so it's easier to work with these numbers rather than the events themselves. Also, we can perform mathematical operations on random variables. For example, we can take averages and add and subtract them, which is a little bit closer to decision making, and we can't necessarily take the average of the 8 o'clock train, the 8:15 train, and a bus. Let's look at a couple more examples of random variables just to get an idea. So if I roll 2 dice, this is an experiment that can have a lot of different random variables associated with it potentially. One of which is the sum of the rolls. And this can take numerical values 2, 3, 4, up through 12. Another example is the number of 6s in a roll of 2 dice. And this could take the numbers 0, 1, or 2. Finally, and this just shows you that random variables are quite general, you could take the second roll and just raise it to the 5th power. And you have these different possible values, 1 to the 5th, 2 to the 5th, 3 to the 5th, etc. All you need is just some number that's associated with each of the outcomes in your experiment. Now, in the next slides, we'll talk more about the calculations and the power behind the concept of random variables.